Have you ever gazed up at the night sky and wondered what it would be like to live and work in space? For over 2 decades, the International Space Station has been humanity's ultimate treehouse, except this one floats hundreds of miles above Earth and is the size of a football field. Yeah, it's not just a floating science lab. It's a gigantic, orbiting testament to what humans can achieve when they put their heads together, even in space. But hold on, how did this high-tech space condo even come to be? What kind of mind-blowing engineering tricks did they use to build it in the harsh, unforgiving vacuum of space? And how did astronauts from around the world come together like the Avengers to assemble this epic orbiting laboratory? Buckle up, because we're about to dive into the story of the ISS, a tale of crazy engineering feats, international teamwork, and a few hiccups along the way. In his State of the Union address on January 25, 1984, President Ronald Reagan directed NASA to build an international space station. The initial proposal was called Space Station Freedom.
Tonight, I am directing NASA to develop a permanently manned space station and to do it within a decade. A space station will permit quantum leaps in our research in science, communications, in metals, and in life-saving medicines which can be manufactured only in space.
He emphasized the invitation of other countries to participate in the project, a goal achieved by the United States in 1988, which was a significant step towards fostering international cooperation.
We want our friends to help us meet these challenges and share in their benefits. NASA will invite other countries to participate so we can strengthen peace, build prosperity, and expand freedom for all who share our goals.
This ambitious vision sparked years of negotiations and planning between the United States, Russia, then the Soviet Union, and other spacefaring nations. Now, the original plan was to wrap up the station in 10 years, but that turned out to be a bit too ambitious. With all the challenges of working across different countries and sticking to tight budgets, it just wasn't realistic. Fast forward to November 20th, 1998. Russia kicked things off with the launch of Zarya, the very first module of the ISS. Zarya was like the Swiss Army knife of space modules, handling propulsion and life support, while supporting multiple docking ports.
Liftoff of the Space Shuttle Endeavour, with the first American element of the International Space Station uniting our efforts in space to achieve our common goals.
Roll program.
Then, on December 4th, 1998, NASA's Space Shuttle Endeavour blasted off on the first construction mission for the ISS, under the command of astronaut Bob Cabana, with cosmonaut Sergei Krikalev on board. The shuttle carried the Unity node into orbit. Their mission? To rendezvous with Zarya and start building the ISS, one module at a time. They pulled it off, and just like that, the foundation of the ISS was born. This moment was more than just a construction milestone. It was a cosmic handshake between the US and Russia, solidifying their partnership for the long haul in the ambitious ISS project. By July 2000, the Russian Zvezda module joined the party, linking up with Zarya and Unity. Zvezda brought the first living quarters and the station's main control center, meaning the ISS was finally ready to host its first permanent crew. Then came November 2nd, 2000, a date that'll go down in space history. Expedition 1, the first ever crew to live on the International Space Station, arrived on the scene. This team, composed of American astronaut William Shepard and Russian cosmonauts Yuri Gidzenko and Sergei Krikalev, kicked off a continuous human presence on the space station that's still going strong today. They had to adapt to life in microgravity, figure out how to live and work in such tight quarters and manage limited resources. Think of it as the ultimate space camp, except this one lasts a bit longer than a week. Then, on February 7th, 2001, the US delivered the Quest airlock module to the space station, finally giving astronauts a proper space to prepare for and conduct spacewalks, or EVAs, short for extravehicular activities. Later in 2001, the Destiny Laboratory module, another American addition, docked with the space station. Destiny wasn't just another pretty module. It packed some serious science power, housing all sorts of equipment for experiments in microgravity across a bunch of scientific fields. Through it all, tight budgets, endless schedule constraints, and technical hurdles kept popping up like space whack-a-mole. But the ISS team never gave up. By the way, let's watch this adorable dog balance on a big red ball. Then, on October 23, 2007, the US added another module onto the ISS called Harmony. Harmony isn't just a pretty name. It's like the space station's grand central hub. It gave the station some extra docking ports for future modules and served as a crucial hallway, because even in space you need a way to get from point A to point B without floating into the wrong module and having to ask for directions. But wait, on February 11, 2008, the Europeans decided they weren't going to be left out of the space party. The ESA, short for the European Space Agency, rolled in with the Columbus Laboratory module. Columbus wasn't just another module. It expanded the station's research, boosted the station's research powers, and gave Europe its very own slice of the ISS science pie, exploring how microgravity affects everything from physics to life sciences. And then, Japan stepped up to the plate with the Kibo module. Kibo took a few flights to get up there from May 2008 to July 2009, but once it was finally all assembled, it added a whole new lab dedicated to Japanese space science. Kibo means hope in Japanese, and it brought a lot of hope for cool space experiments. Plus, it's fun to say. Then, over a decade later, there was Nauka, the long-awaited Russian module, also known as the Multipurpose Laboratory Module, or MLMU. After what felt like an eternity of delays, Nauka finally docked with the International Space Station on July 29, 2021, and brought with it some sweet upgrades, like new research capabilities, a fresh docking port, and an even better toilet. Because let's be real, when you're living in space, a good toilet is non-negotiable. That same year, they added the European robotic arm to the Russian Nauka module, giving the station a new set of hands and boosting the ISS's ability to do maintenance, repairs, and deploy payloads. And from 2021 to now, we've seen the rollout of the Erosa solar arrays, which are basically supercharged space batteries. Developed through a joint Russia-US venture, these arrays are set to crank up the station's power generation, making sure the ISS stays lit. Of course, building the ISS hasn't been all smooth sailing. Every launch and every new module had their struggles, and keeping the aging station in tip-top shape is also an ongoing challenge. But hey, that's space for you, always throwing curveballs. The ISS is more than just a space station. It's a symbol of international collaboration, pushing the boundaries of what's possible in space. Every module, every experiment, and every challenge overcome has brought us closer to understanding space and our place in it. The ISS isn't just a floating tin can. It's a vital lab for studying how space interacts with living organisms and materials. Since becoming fully operational, the ISS has been the ultimate science playground for scientists. From growing plants to studying microbes and human cells, scientists have discovered a ton about how microgravity affects life. Scientists have also studied everything from fluid behavior to crystal growth. even how fire behaves in space. The research has led to breakthroughs in material science, fluid dynamics, and biology, with real-world applications here on Earth and beyond. This knowledge is also crucial for future space missions and could even pave the way for manufacturing in space one day. Want to know more about the accomplishments of this incredible space station? Hit that like button, subscribe to our channel, and hit the notification bell for more exciting deep dives into space exploration. The International Space Station, a marvel of international collaboration between 5 space agencies, NASA US, Roscosmos, Russia, JAXA Japan, ESA Europe, and CSA Canada, has faced ongoing challenges despite its successes. While the ISS currently supports valuable research with a crew of astronauts and cosmonauts, some of its modules are nearing the end of their designed lifespans and haven't been without problems. Keep watching if you want a closer look at some of the ongoing challenges the ISS faces, along with specific examples. The first pieces of the ISS, Zarya and Unity, launched in 1998. Yep, the same year we were rocking out to the Spice Girls and waiting for the next big Pokemon game. These modules were designed to last 15 years, but guess what? They're still up there doing their thing more than 2 decades later. Talk about space antiques. But like any old machine, they need constant upgrades and maintenance to make sure they don't turn into space junk.
But it's starting to show its age.
Astronauts launched a very complicated series of spacewalks today to fix a cosmic ray detector at the International Space Station.
Space is a harsh environment, and we've seen over the past couple of years small leaks appear within the space station. These are not life-threatening, there's nothing serious, but it is an indication that the lifetime of the International Space Station might be coming to an end.
One specific example is the 2019 air leak in the Zvezda module. This minor leak highlighted the difficulty of repairing an aging spacecraft in orbit. Finding and fixing that leak took some serious international teamwork and a whole lot of planning. This little incident reminded everyone that keeping the ISS in top shape isn't just a one-and-done deal. It's an ongoing mission. By the way, here's a photo of 3 giraffes staring at each other. However, building and maintaining the ISS requires significant financial resources from all participating space agencies. It takes cold, hard cash, lots of it. Tight budgets can limit the pace of upgrades and introduced scheduling constraints. But even with budget constraints, it was still a real challenge to coordinate efforts among multiple space agencies, especially when they each had their own priorities and procedures. For instance, ensuring the compatibility of life support systems and crew procedures required ongoing communication and collaboration. One significant challenge arose in 2020 when a software glitch caused a brief loss of communication between the Russian modules and the rest of the ISS, highlighting the potential risks of communication breakdowns. And here's the big news. Russia plans to pull out of the ISS by the end of 2024 to start building its own space pad. This could throw a wrench into the works because Russia's been a major player in the ISS from the get-go. But despite these challenges, the ISS keeps on ticking. Engineers are constantly working to address all these issues.
The ISS could have its longevity shortened further by this announcement from Moscow. Yuri Borisov, Russia's new space director, tells President Vladimir Putin, quote, "The decision to leave the station after 2024 has been made, so Russia can begin building its own space station." Putin's response? Good.
The International Space Station stood as a testament to human ingenuity and international cooperation. However, its future path had become shrouded in some uncertainty.
The International Space Station is currently approved to operate through at least December 2024 with our agreements with the international partners. However, as we are actively working to continue to do science and research, we understand that the ISS at some point will have its end of life.
Looking ahead, the ISS might just get an extension beyond 2030 if everyone plays nice and ponies up the cash for more upgrades. But with Russia planning to bow out, there's a chance the remaining partners might have to downsize the station. So, what happens after the ISS extension? Well, the space station's going to be deorbited and make its final splashdown in the Pacific. And guess what? SpaceX has the contract to handle the whole deorbiting process. The rise of private space companies like SpaceX and Blue Origin has been transforming the space industry. These companies weren't just pushing the boundaries of launch technology with reusable rockets. They've got their eyes on building and operating their space stations. Yep, private companies want in on the action, and they're not just dreaming. They're already partnering with NASA to develop new modules for commercial space stations. These private space stations could change the game, offering more flexible and specialized modules, kind of like a cosmic build-your-own adventure. They're even talking about luxury accommodations for space tourists. Fancy a room with a view of Earth? In the future, that might just be a reality. Of course, it's not all smooth sailing. Building space stations isn't cheap, and there are tons of regulations and safety checks to pass. But with the potential for big money from research and tourism, the incentive is huge. Picture a future where space stations are as common as skyscrapers, buzzing with scientists, explorers, and the occasional thrill-seeking tourist. And that's the story of the ISS, a testament to human ingenuity, teamwork, and a whole lot of rocket fuel. But don't think our space journey ends here. So what's next for the ISS? It's likely to retire no later than the 2030s, paving the way for a new era dominated by private space exploration and tourist space stations. One thing's for sure, the ISS has already secured its legacy as a pioneer in space research and international cooperation. Want to know how SpaceX won the contract to deorbit the space station? Watch this video to find out more about that.